Hello and welcome to today's webinar titled Maintenance 4.0 in the Electronics Manufacturing Services Sector. Today I will be your presenter. My name is Edgar Blazek and I am an EAM Business Development Manager working for LLP Hungary. A little bit about LLP. It was founded in 1992 and we currently have offices in 9 countries throughout Europe, North America, and Latin America. We are, at its core, global systems integrators supporting projects around the world, and we have already successfully delivered 700 projects in more than 70 countries across 5 continents. All of our consultants for Infor EAM, which I will detail a little bit later, are certified by Infor, the company who has developed it. Most of the team actually comes from DataStream, which is the predecessor software that is now in Infor EAM. So the vast majority of the team has 25 plus years of experience when implementing enterprise asset management in a variety of sectors. For management and process presentation as examples in this webinar, I will be showing you Infor Cloud Suite EAM. This is Infor's industry-leading enterprise asset management solution because it is recognized by third parties as the closest true Industry 4.0 solution. The solution supports specialized requirements for asset and work management, materials and procurement management, budget and inspection management, and project and safety management. These are all required for a true Maintenance 4.0 solution. To indicate how this system actually uses everything, I've just selected a few companies that use Infor EAM. I would highlight CERN and NASA, for example, but if we're talking about electronics manufacturing sector, we can see that Flex, GE, Valeo, Lear, Honeywell, Siemens, etc., all use Infor EAM for their maintenance and asset management operations. Now, let's review what Maintenance 4.0 actually is. Maintenance 4.0 is the next level in efficiency. It helps you manage not just your maintenance operations, but your people, your contractors, and your network as well as your machinery. It helps you create an MRO that is built on industry best practices for asset management that have been crafted through years of evolution and refinement to help you embrace Maintenance 4.0 on an organizational level. In order to review the entirety of the solution, I would like to take you on a tour of the main functions one by one. My aim is to present how these individual functions work together to form the entirety that is Maintenance 4.0 or enterprise-level asset management solutions. Now, at its core, it starts with managing your assets, not just your machinery, but your assets as a whole. Of course, capital equipment and equipment used in PCBA production, but also buildings and facilities, fleets such as service cars or forklifts, or AGVs that bring the components to the lines, network assets, and of course linear assets like tubes with nitrogen or cables in the walls. In EAM, this is done by defining and creating a hierarchical structure for all assets. This structure is important for determining asset relationships. It will help you have proper transparency of your entire asset inventory, from operational equipment, from the S&T lines, all the way to spare parts. In this example, you see that the structure is the city, the site, the production cell, the line, the machine, and its parts of the parts, etc. This is incredibly important to see which part is associated with which machine. Of course, every asset needs to have its full documentation, which part can be used for which asset. It's interesting to know that even if you have the same supplier for board handling equipment, for example, in Spare parts and how the machine actually works can change from year to year. Even if you have just 3, 4 year old machinery, the changes in spare parts can be astronomical. Now, keeping track of which axis, which bearing is okay for which machine is a big task, and it needs to be automated to achieve proper efficiency. Of course, the documentation also needs to include the suppliers, lead times if you order the spare part, metering data, for example, and cost codes. Now, this information can be in an enterprise asset management solution like Infor EAM, or it can be in the ERP system. It's actually better to have it in the ERP system and have proper communication so that this information is updated on a regular basis. I will get into this a little bit later. One of the key benefits of implementing a solution like Cloud Suite EAM is that it provides efficiencies in the management of your maintenance team. It provides a comprehensive solution to manage labor and contractors, materials used in the maintenance operations, the purchasing of materials and spare parts used in the maintenance operations, work order scheduling, which we will detail a little bit later on, capital planning, of course, using system data to understand the true cost of repairs to assist in the repair of replace decisions. Projects. Project management is also very important, and you need to be able to schedule preventive maintenance projects or new equipment installation at a moment's notice. And of course, safety and regulations. You need to keep track of inspections and regulatory compliance issues with clear reporting. This is how the maintenance schedule planning works in EAM. You can hover over any day with your mouse to see the actual work order assignments for the employee. Once again, the employee can see those work order assignments too on his or her initial sign-in screen. This whole schedule is intuitively made by drag and draw functionality, where you can simply just drag a given employee and put it on the given task at a given time. You can also manage authorizations and certifications. This is very useful in case you have processes that involve trainings or certification requirements. In case of SMT, a good example is the X-ray inspection process. There are tasks that are no problem for maintenance personnel without X-ray certification, like changing a bearing or an axis inside a machine. But if the X-ray tube needs to be serviced or planned readings need to be taken to ensure ongoing safety, it can only be done by personnel who have the required certification. In Infor EAM, this is done automatically. If you want to have an employee do a specific task, it will check if he has the required certification. If he does not, it will notify us, or if it is configured as such, it will not allow you to try and put that employee for that work order. Maintenance 4.0 is also important, of course, in project management. Infor EAM is, for example, a comprehensive tool for project planning and organization, project budgeting, and scheduling and execution of the project. It does this by automating the administration and time scale planning from the initial budget to the completion of the final work. It can also compare the current status of work and resources to the planned work and the budget. As we continue, we look into adopting industry best practices by moving from a purely reactive maintenance model, where if something breaks, you go and fix it, to creating a preventive maintenance model to reduce the amount of downtime due to unexpected equipment failure. Maintenance 4.0 provides a framework to condition-based maintenance through the use of meter readings and IoT sensors. This provides data that can trigger alerts that help in scheduling maintenance activities. Using this data and the machine learning features built into the underlying operating service, you can move to a predictive maintenance model that allows you to analyze common failure points and anticipate when a particular piece of equipment is likely to break based on hours of service or other factors. The main focus is to reduce wasted resources to achieve peak efficiency and the best possible return on investment on every single asset. This means that accurate real-life data needs to be used to manage the entire life cycle of the assets. By managing your assets, your maintenance team, and your maintenance activities, you will better manage the asset's performance, leading to savings on the bottom line, particularly in the area of energy management and how older equipment is usually the chief cause of excess expenditures. For example, with multiple lines of production producing the same product, similar machinery, we will be able to see real-time data on current energy consumption, since this is a key indicator of anything is going wrong. We can also take advantage of condition-based monitoring to analyze the performance and identify areas where savings can be realized. If we're talking about asset performance management, Gartner groups APM into four main quadrants: asset strategy and risk management, detailing regulatory compliance with risk-based inspection; reliability-centered maintenance, with a high emphasis on root cause analysis; predictive maintenance, based on accurate statistical data usage; and, of course, condition-based maintenance, which, as we've discussed, is the desired quadrant. As you can see, accurate data usage is incredibly important to reach all fields. I would only like to emphasize two quotes that I usually tell to clients that I have discussions with. One is, without data, you're just another person with an opinion. And having the data is easy, you need to use the data as well. This highlights that a lot of people actually claim to have all the data at their fingertips, and this might be true, although I am always concerned about the accuracy of that data. It is not so easy to use that data efficiently. Data management is one of the key problems most of these organizations is facing. With Maintenance 4.0, you can take your overall equipment efficiency, or OEE, to the next level by incorporating energy intelligence into your asset management strategy. Using this, you'll be able to uncover hidden waste, use sensor data to monitor equipment condition to trigger alerts, of course, make data-driven decisions when balancing the costs of repairing or replacing equipment by adding energy costs into the equation as well, and quantify the financial impact of energy costs. This is important because of how much energy we actually use. Electricity consumption in the United States was approximately 4 trillion kilowatt hours a couple of years ago, and more than 22.3 trillion kilowatt hours globally. In the United States alone, that's a cost of almost $550 billion per year. But why is this important? Well, it's estimated that the energy costs can account for more than 50% of operational expenses in the manufacturing environment. Without a comprehensive asset management plan, it's likely that you'll experience energy waste as high due to operational inefficiencies in a wide range of equipment used for both facility operations and manufacturing process activities. Those inefficiencies lead to decreased asset performance and a decrease in the useful life of the asset as well. As an example, if a three-phase motor has phase imbalance, that means that it's using approximately 12% more energy than it should. This does not look like much, but when you extrapolate it to the entirety of the manufacturing environment, the cost savings that can be realized here are simply astronomical. And I would like to point out that this is not an error or an issue that you could actually find or see or catch without the proper management of data. For using the data to its full extent, analytics and reporting are needed. This needs to be automated to avoid any human errors and to speed up the process itself. In Infor EAM, KPI dashboards and charts are used for reviewing crucial information. Depending on the user's role, the KPI dashboard can be configured with meaningful data for that particular user. All of this is possible by leveraging the data lake that serves as the central repository for all the system data. As you can see in the example, the first screen when you log in the Start Center contains charts and KPIs that help in the transparency of operations to better drive decision making. These charts and KPIs are, of course, fully customizable and can be tailored to any role. In addition to KPI dashboards I've shown you, there are custom reports that we can and have built. Here is an example of a repair versus replace schedule for a piece of equipment. In this example, we're using a stencil printer that's commonly used in the SMT process. It includes depreciation and maintenance parameters based on historic costs. As the book value of the equipment decreases, the cost of repairs will generally increase, and this corresponds to a rise in the cost of ownership as well. Our report writings tool empower you to access and format this kind of analytical data so that you have greater visibility and can make more data-driven decisions. In this example, it is clearly shown where the proper time to replace the equipment is, where its overall costs in yearly maintenance actually exceed that of its book value. Another key feature of Maintenance 4.0 is its interoperability. Infor EAM, which is built into the underlying operating service of Infor EAM, allows for document management and the flow of data from things like archived documents and SCADA. As for some other examples in connections and interoperability, let's go into it in a little more detail. GIS positioning is used in order to have knowledge about where your assets are at all times. This geographic information system helps in locating exactly where the given asset is, or where the work for a given work order needs to be done. For increased functionality, it is possible to have additional functionality like Google Maps, for instance, for added route advice, etc. BIM and CAD drawings can also be incorporated into EAM. This is incredibly useful for a manufacturing environment as well as for facilities management. You are able to see assets inside walls or underground, or you are able to see exactly where the given asset or spare part is inside the machine. Now let's take a look at the end result of an optimized approach to maintenance. Improvements in the efficiency and effectiveness of your maintenance management strategies will ultimately impact your maintenance technicians. Here we can see that work orders are delivered to technicians on a mobile device Infor EAM's mobile application, regardless of why the work order was created. The work order could have been created automatically based on a preventive maintenance schedule, as you can see on the left, or it could have been created manually because of a breakdown, as you can see on the right. The technician doesn't really care why the work order was generated. They just want simple and just-in-time access to all the information they need to get their work done. They also want to be able to access documentation, like manufacturer specifications, videos, JPEG files, that show them how to complete the respective repair. By having information available immediately on their mobile device, trips and telephone calls between the field and the office are reduced substantially, and overall employee productivity increases. That means higher operational efficiency and greater labor savings for you. Proof of delivery allows you to capture the signature of the person that work is being performed for. This signature will be associated as a document for this work order. In Infor EAM, you are also able to incorporate data in this document, like the activity time or the costs of the work order. Of course, this information can also be forwarded to the financial system for full visibility and cost transparency. It is clear to see how each component of the system works together to provide a comprehensive enterprise asset management solution that provides benefits for each aspect of your organization. Here I would like to show you some examples inside the SMT manufacturing process. This is a typical SMT line. If an error comes up on the AOI, for example, by the time the error is identified, there are multiple boards already manufactured, and in the high-end manufacturing industries like automotive or aerospace, you are simply not allowed to repair the boards. This means that since high-value boards that contain BGAs and QFNs cannot be repaired, we have already lost 4 to 20, based on the process, products before the error was even identified. If we're talking about a board that costs between 500 euros to somewhere around 10,000 euros, you can kind of calculate for yourself how big savings it can actually lead to if only one of these errors are caught per year. This cost is, of course, above the normal downtime cost, which means that the machines are not working, so they're not producing any money. Another good example is the stencil printer. With condition-based monitoring, we are able to identify issues directly on the manufacturing machinery themselves, like the stencil printer, the pick-and-place machine, the reflow, and reduce, if not eliminate, costly errors in them altogether. In this example, if the SPI identifies an offset in the printing process that is still within error tolerance but quantifiable, we can set up an alert in EAM that will automatically message maintenance personnel to examine the screen printer to determine if corrective action needs to be taken or not. This way, we can bring error numbers down to a minimum before the issue compounds, and by taking corrective action, we can reduce the potential cost of errors and major repairs. EAM is also helpful in gathering useful information and statistical data for any wear and tear spare part, like stencils, the knife, etc., inside the printer. This is useful for identifying good quality price ratio products and extend asset life with a noticeable increase in utilization. It can also be used to generate useful competition in suppliers by showing them the quality of their products against their actual cost. Reviewing NG data can be very hard, especially if the root causes are not known to us. To determine this, we can communicate with SPIs and AOIs to receive information on the type of errors on the board. The information on the machine in question is at our fingertips, its maintenance history, its owner, its spare parts inventory, etc. And the system can generate a work order based on the data gathered from the inspection machines. For example, if we have an AOI that can determine which actual machine in the pick and place process produced the error, for an example, a Koyang AOI, it can send that alert to, we can steal that alert and send it to the proper maintenance personnel who will go there and check out the machine with its whole historical data and documentation to see the process in its entirety. This is incredibly useful because if we have one issue, then that's an error that needs to be fixed. If it happens again, then in all due likelihood, it is not the error itself, it is a symptom of the error. This is why root cause analysis is so important. We need to be able to find the underlying error before it causes even more damage to the machinery and to the production process. And of course, errors that stop the lines can come from not only the lines themselves, but from various areas that are out of the view of the operators or the people responsible for planning the production. For example, if feeder maintenance is not properly performed or their location is not known 100% of the time, it can create issues where the lines do not get components in time. A complete overview of all required maintenance in all departments and proper planning and execution is needed for stable production, which you can plan with. This is called reliability. In these trying times, we need to consider the health and safety of our employees in new and challenging circumstances. This is where Infor Cloud CDEM's flexibility shows. Creating the following scenario in Infor EAM is just a process setup and requires no additional services after implementation. Let's see the example of a COVID-19 case cleanup scenario. A message is received that one of the employees tested positive for COVID-19. The system automatically creates a ticket for review. The manager reviews the ticket. He can either create the work order and assign it to the contractor, in this case, a cleaning and disinfection crew, or by setting up the proper processes. EAM can create the work order automatically, and the manager only needs to confirm it. The contractor receives the work order and does the task. When the task is marked as done, the manager can see that the work order is closed. It is important to note that while this process looks easy, it requires the underlying processes and documentation to be accurate and ready. For example, the system needs to know where the employee was at a moment's notice to be able to create the work orders as fast as possible to avoid further infections. I would like to present to you Infor OS as well, which is an operating service that brings business processes and artificial intelligence together to enable rapid application, development, and a common data strategy, providing a unified experience that allows you to be flexible and agile in cloud environment. OS allows the collaboration and integration between both Infor software and non-Infor software. It's able to collect data from SCADA and IoT sensors, as well as historical or archive condition monitoring, and share that information data through APIs and BODs using ION, which is an integral part of the OS platform. One of the more powerful features of Infor OS is business process integration. Using the drag and drop modeler, you can create simple to complex workflows by choosing from a library of pre-built connectors and patterns. It features built-in validation and versioning so you can continue to build different processes and settle on the one that works best for you. As I mentioned earlier, ION serves as the middleware that allows you to eliminate operational silos and achieve unparalleled end-to-end efficiency. It allows the ERP system that you use for finances to communicate with your asset management system, EAM, and share data regarding inventory and costs. This level of automation and cost transparency leads to an overall efficiency and better data management. This is simply required to have the proper statistical data and accurate statistical data at that, so you can plan and see where the bottlenecks of your entire manufacturing process is. Now let's talk about IoT and devices and how OS and EAM actually communicates and manages them. You can use this business process integration, which I've shown you, to collect data from IoT devices and additional sources and manage them to trigger alerts or generate work orders. It doesn't matter where the data actually comes from. It can be SCADA or PLC, historical data, or any kind of automation in the building itself. It enters the system, and through its algorithms, it checks for exceptions, alert history, it cross-checks for schedules, and the predefined business logic, and after that, it generates either a notification, alert, or work orders or work requests. As an example of monitored data, let's suppose you have a pump as part of the machinery that supplies the flux, for example. When it's operating in the green at an acceptable pressure level, everything is great and no action is necessary. But just as SPIs and AOIs have soft and hard limits, so too must we use it in any kind of other sensor. When it reaches the buffer zone and the soft limit, we can set algorithms. If it reaches it once, it can generate an alert or notification. If it reaches it 3 times, 5 times, 10 times, it is all down to the process that the client requires. But of course, if it reaches the hard limit, the critical value, then it automatically can generate a work order for the technician to go and check it out as soon as possible, because this way we are able to realize cost savings by simply knowing where the issues are. We can eliminate unplanned downtimes and even save the assets themselves. If smaller correctional maintenance is enough to keep the machinery running, it is a big increase in the asset's overall life. This data can then be used together with public data, third-party data, and the cloud suite itself in the Infor data lake for additional topics like analytics, custom apps, and this data can be used for the PM, which is business intelligence, or it can be transferred to other IoT apps. This can also be used for risk assessment and compliance, and it is a repository of data that is very useful during audits. Just imagine, as you're walking down the lines, the auditor asks for specific certifications, data, or anything as such, and you can just bring your mobile and show him or her the required data on a moment's notice. And here is an example of sensor-driven work order creation. The sensor device sends data about the asset. The rules engine then evaluates against the previously established threshold and generates a review request that's sent to the maintenance planner. The maintenance planner is then notified of the alert and determines the appropriate action and whether it should be escalated to a work order or not. This is a good example on the starting run, but as we gather more historical data, it can actually be cut from the review request all the way to escalating the work order itself automatically, although the best practice based on experience is still that the maintenance planner needs to review it and confirm the decision of the rules engine. Let's have an automated process example here. I would like to show you Rapid Request. Rapid Request is one of the mobile applications associated with Infor EAM. It is a tool that allows the reporting of a problem by practically anyone. This is how it looks like. It can be used on any mobile and is a huge help in the management of service cases. The system allows the opening of a new case with a rough description, while the contact information and associated documentation is already in the system. But instead of detailing it, I would like to show you through an example. This is an example scenario called the power outage. Made by Infor, it showcases the usage of Infor EAM, Infor OS, and the mobile applications Infor EAM Mobile and Rapid Request. As you will see, simplicity in usage like this requires the underlying processes to be fully functional and realized. Here, Warren reports the blackout with his phone. He uses voice recognition, but he could also type everything in as needed. His geolocational data is automatically generated. He can also take a picture to illustrate the problem if he needs to. Once he has sent the request, InfoOS automatically confirms it through an email. Artis, the facility manager, receives a notification on Infor EAM mobile and sees that there is work to be done. He first assigns it to himself, as he will be responsible. After that, he assigns it to a technician, who in this case is Martin, and simply marks the task as done. Martin, again on Infor EAM mobile, sees that there is a new task he needs to do. Well, he already has all the required information, like what he needs to do, where he needs to do it, and he can check the activities. He can start it and get to work. In this case, of course, it is just a simple fuse that or switch that needs to be put back online, but it showcases how it works perfectly. He adds a comment that the power is back online, and he can also attach any kind of documentation, like pictures or drawings that is needed for full documentation of the given work order. Once this is done, he stops the activity and checks if the booking of labor is accurate. Once this is done, he has practically nothing else to do but go and close the work order, mark it as complete. Once this is done, the facility manager receives a notification that the work order has been completed. And at the same time, Warren, the supply chain director from the beginning, receives a satisfaction survey where he can give his impression on and the data on how much the problem was an issue or how much time did it take to resolve the issue, and of course, how was the technician, etc. Of course, this information and everything can be highly customized. And as you see, this this process is not really complicated either. What it requires the underlying processes to be set up efficiently, and it requires access to the documentation and data on a moment's notice. This functionality is reached by implementing our step-by-step methodology. This methodology details both the implementation strategy and the continued project support. The main goal is always to set up a strong foundation in knowledge about the system as well as in the processes. Without this foundation knowledge and a proper enterprise asset management system, we can have a basic and inaccurate asset records list. We can also have a basic MRO inventory holding. We will be able to have processes that give us a rough and more often than not inaccurate picture of our current state and capabilities. We could even try to make depreciation calculations for individual assets. However, having a strong foundational knowledge, experience, and company-specific processes can yield incredible results in transparency and overall profitability. The step-by-step methodology guarantees that each new process is built on a working and understood foundation to provide additional functionality and cost savings. And where is the value? The value is realized when InfoCloud Studio EAM's full implementation is done, like increased labor productivity, a reduction in maintenance, overtime labor and contractor costs, reduction in new equipment costs, in MRO material costs and MRO inventory levels. We have noticed a great increase in warranty cost recovery. This is not surprising. This issue is usually because the companies don't have the proper documentation or information to properly request warranty on specific machines, or they simply just don't know that their machine is still under warranty. We also have reduced energy consumption. And as we've discussed, that is a big gain on its own. And of course, having a fully transparent and traceable documentation and invoicing system is a great big increase in the overall processes of the entire organization. These are the reasons why the return on investment for Infor Cloud City EAM is simply second to none. Thank you for your time and your attention. If you have any questions, I am at your disposal.